Now we will look at the functional benefits of linear algebra, the why. Like why we should use linear algebra or why linear algebra is powering the modern AI. The functional benefits of the linear algebra, like why we should use linear algebra or why the linear algebra is powering the modern AI. So representation. So linear algebra provides a universal language. Whether you are translating French to English or identifying cancer in a X-ray, so whether you're translating, identifying, doing some kind of a recognition, linear algebra represents both problems as operations on numerical arrays. So linear algebra provides a universal language for representing the data. So regardless of the operation you are performing, if you represent the data in the form of vectors and matrices, you can solve problems. So that is what the linear algebra is. So now it's very clear that why linear algebra powers the modern AI, because linear algebra provides the universal language to represent the data. Computation. If we talk about modern hardware like the GPUs, they're specifically designed to do one thing extremely well, that is the matrix multiplication. So modern hardware, they make use of like GPUs. So GPUs are designed for matrix multiplication. GPUs are designed to carry out billions of simultaneous calculations. So linear algebra allows us to perform billions of calculations simultaneously rather than one by one. So now it's very clear to us that linear algebra, why it powers the modern AI, because it provides the universal language to represent the data. It provides the computational framework, because modern hardware like the GPUs, they make use of linear algebra, they make use of matrix multiplication to carry out billions of simultaneous calculations. Structure. So linear algebra, it turns chaotic data, unstructured data into a rigid geometric grid. Because with linear algebra, we are treating data as geometry. So linear algebra, if we represent the data using the concepts of linear algebra, then we are turning the chaotic unstructured data into a geometric grid. This structure allows us to use concepts like distance and angle to find invili- relationships between data points that would be invisible to human eyes. So once we convert the chaotic unstructured data into a geometric grid, we can use concepts like distances and angles to find the invisible relationships between the data points. And this is how the linear algebra is powering the modern AI. And also we have efficiency. So techniques like dimensionality reduction using SVD, PCA, like singular value decomposition or the principal component analysis, it allows the AI to process massive data sets by focusing only on the components that matter, drastically reducing the amount of memory and power required. So dimensionality reduction is also a concept of linear algebra. So with linear algebra, we can also achieve efficiency, wherein we can process massive data sets by drastically reducing the amount of memory and power required. So now it's very clear to us that why linear algebra is powering the modern AI. Linear algebra provides the universal language to represent the data. It provides the computational framework like the matrix multiplication, using which modern hardware like the GPUs can carry out billions of simultaneous calculations. Linear algebra provides structure, like it can turn a chaotic unstructured data into a geometric grid, structured data. Using linear algebra, we can treat data as geometry, which allows concepts like distance and angle to find invisible relationships between the data points. And linear algebra, it also provides efficiency, wherein we can use the concepts of dimensionality reduction to process massive data sets using reduced memory and power consumption. And hence, linear algebra is the hidden engine behind artificial intelligence.